Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, artists, you name it, all across the world of crypto and blockchain. And today I have another amazing guest for you. He is the co-founder of Exocore. His name is Warren Anderson. Warren, welcome to the show.
Hey, thanks for having me on.
You're very welcome. So let's kick things off. I'll ask you the first question is, what is your background, and is it a logical background for what you're doing now?
The answer will reveal the second part of the question. I have been in crypto full time for over 10 years. And so I barely remember what it's like to not work in crypto. But basically I got started mining Bitcoin back in actually 2011, caught the tail end of the CPU phase, basically played around with Bitcoin, learned how to and not to trade cryptocurrencies. In 2013, I said, I'm staking my career on this technology and started a company called Hedgy, which was the first DeFi platform, full stop. It was actually built on Bitcoin using Bitcoin script. We were building smart contracts before Ethereum actually existed. It was the first OTC wholesale platform for any cryptocurrency. So at the time, Bitcoin miners could only sell on exchanges, created a lot of volatility. So we created a platform for them to sell direct to institutions. We built a great platform, great product, ran into some regulatory headwinds. And then I joined Ripple in the summer of 2016 to lead all of their crypto products and protocols on the product side. So at Ripple, I was there for 5 years, which is an eternity. But I got to work with the core developers of the XRP Ledger. Got to work very closely with the early kind of community of the XRP army. Also created their On-Demand Liquidity product called ODL, which has become their flagship product for cross-border payments. So I had a good tenure there. After 5 years, I woke up and said, it's time for me to move on. And I joined a ZK project focused on privacy. It was just in the research phase at the time. We took it from research into production. It was formerly called Findora, and spent 2 years kind of developing that, getting really versed in kind of the ZK ecosystem. And we had a great time, kind of grew the contributors list from a handful to, I think, over 80 people were working on the project full time when I left. So, and then, I kind of took a pause and I wanted to do something from scratch, start my own thing again. And I kind of went back into notes, saying what's the most interesting thing I've seen in crypto in a while. Restaking was triple underlined. I had heard about it, kind of conceptually, but at a high level, theoretical, where Sriram gave a talk at Stanford Blockchain Conference. And so decided to dive in deeper. This was December 2022, January 2023. And then I brought together a couple close collaborators, RJ Lon, the former co-founder of Harmony, and Raluca Adepopa, is a professor at UC Berkeley in cryptography and security. We all have a background, in security and building these crypto products and services, especially RJ and I. We've built bridges, we've built oracles, we've built a lot of what you call now these restaking AVSs. So we're coming from a perspective as a user wanting to build restaking tools for developers, as users of the tools ourselves. And so that's really how my background is so relevant, because we've experienced the pain point that these users have faced, and we can empathize with them and build a product experience that really, really resonates with them.
Oh, so your background's pretty logical. So you did say something that you said Bitcoin script, and when I hear Bitcoin script, I think of Litecoin. You know, but then XRP, that's pretty good. Okay, so now you're building Exocore. We're going to get into restaking. The first thing is you have a mission to power an open market for decentralized trust. That's needed. How do you do it?
Yeah, I think it's important so we started with kind of carving out some core principles. This Exocore is a very decentralized project. This differentiates from kind of other restaking projects in the space. And so really ironing out what does that mean? Open market for decentralized trust should be decentralized. So that means from having open, community governance. Exocore is implemented as a layer one blockchain that's optimized and specialized for restaking across different L1 blockchains. So what it really means is it's aggregating the decentralized trust or the decentralized security of different blockchains and extending that decentralized trust to other services like off-chain. So this can be classically bridges, oracles, even AI networks. It gets into a lot of even Web 2 networks that are looking to inherit decentralized security to power their infrastructure. Why would they want to do that? Because it's censorship resistant, it's immutable, all the properties that decentralized services kind of provide. We can do that by allowing them to inherit this without having to bootstrap their own decentralized network themselves. So that's really what we think is exciting, creating this open market for decentralized trust, which will actually create an actual concrete value and there'll be actual price discovery around decentralization. So we think that's really important.
Very cool. So I want to get in. I want to get into restaking. What is restaking, and then what is union restaking all about, and what problems are you trying to solve with this new union restaking approach?
Sure. So restaking has kind of evolved off the backs of the proof of stake classical staking. So classical staking is you basically take a token and you commit that token to being locked up to secure a network such as Ethereum, and for the upside of getting some type of reward or yield, and the downside of it being slashed in case there's any issues, on Ethereum or any of the protocol you're securing. Restaking takes that and extends it where you can take that exact same collateral that you've proposed and is locked up and literally stake it again. And when you stake it again, what you're saying is, I want to take this existing collateral, use it to extend and secure additional services outside of the Ethereum or whatever blockchain. And for the same, or similar reward mechanism, I'll earn a reward for doing that at the expense of potentially that being slashed if there's any, violation of the protocol rules by the service you're being secured by. So that this mechanism is really powerful, and huge hat tip to Sriram Kannan and Eigenlayer for kind of inventing it. We have evolved that restaking kind of mechanism, and we're introducing it, reintroducing it, where we believe that or like single chain restaking, which is classically what Eigenlayer does, is you're taking Ethereum or native ETH or some liquid staking form, using it to secure services on Ethereum. There's a project called Babylon, which is doing what we call cross-chain restaking, which is taking Bitcoin, restaking Bitcoin, and securing services on like Cosmos. What we're doing, and we view that as the single chain restaking is kind of like single player mode, right? It's fun to play a video game where you're just like you and the computer. And then the cross chain is more like multiplayer mode, where it's you and a friend, in your room, kind of playing together. What we're introducing is the basically taking single chain restaking, cross chain restaking, and then also introducing something called union restaking, which is the ability for AVSs, these services that you're securing, to also restake to each other. So this drastically kind of changes the plane for how restakers can secure these services. We call this this is omnichain restaking or massive multiplayer mode. So this is really exciting because it unlocks a lot of value across, and it changes a lot of the risk reward kind of ratios across the field.
The way you explained it, I get it. I understand it. But you said multiplayer modes. It makes me think of like gaming. But
Yeah.
you have a DeFi background. This isn't really gaming. It's really people's finances, right?
Correct. Yes, it's definitely, and I think the term GameFi kind of comes in. We're just using it as a description of like how the different, like a mental model for how people can grok this. Although I will say that we're about to launch testnet and in a kind of decentralized, kind of open fashion, and there will be a lot of gamification that's kind of around the experience. So we've taken some time to make that experience really kind of fun, and we think users will really love it.
Very cool. Okay. So then you said the word omnichain, right? You're aggregating decentralized security, right? As you have a secure system into this omnichain. How do you add the security layer?
Yeah, it's a great question. So the security that we're talking about, there's kind of two forms, right? There's your classic cryptographic security, which is using all these cryptographic primitives to make sure that things are behaving properly on the protocol. Then you have your crypto economic security, which is classically, basically the incentive to reward good behavior and punish bad behavior. That's what boiled down to what kind of in layman's terms. So we kind of stand right. Exocore kind of stands right in the middle, where we're extending the crypto economic security to these other services, but also powering a lot of cryptographic security in the same sense. So it helps to have one of our co-founders be a cryptographer and security expert to really help kind of create that security design at the architecture level. So we have a little bit of both, where blending crypto economic security with the cryptographic security. And we think that's the sweet spot.
I think it's a sweet spot too. You've seen all these news articles about bridge attacks and hacks and everything. So I think that helps to have an expert in cryptography on your team.
Absolutely. And RJ and I have been on both sides of these bridge attacks, right? We have been victims of the bridge attacks. We've also spotted exploits where we've responsibly disclosed them to the developers to patch them. So we know how painful it is, and we've experienced that pain firsthand. So we wanted to build the solution to help solve this once and for all, because you can't have a token economy without secure bridging. And anyone that kind of says bridging should never happen is not unrealistic. You have to have a way to hop from one blockchain to another in a secure fashion. So we really spend a lot of time thinking about that.
And it's in your white paper. You work on mitigating attack vectors, right? How do you do it on your chain? And then I want to ask you another question about attack vectors after that.
Yeah, so we took a security by design. Most people, when they talk about security, they just flash a bunch of like audit badges and say, oh, it's secure. See, the audits say. We are security practitioners, so we believe that the system needs to have a secure design, and only in that design it starts at the whiteboard level. So we identified three different areas where we need to harden the security, or basically they're called trust assumptions, where we had to really make sure that the trust assumptions were reasonable and managed really well. The first one was, as a layer one protocol, we need to ensure that the protocol itself is reasonably secure. So what we chose, we implemented Tendermint for consensus. And why we implement Tendermint is it's battle hardened. It's been out for many years. We can rely on it. It scales reasonably well. And it doesn't introduce any kind of novelty in the system. There's no knock on novelty, but sometimes novel systems can come with security issues. So we chose to implement that. It's also pluggable. Exocore is a very modular blockchain, so we can kind of swap things in and out. If something else comes, in the future that's better than Tendermint, then we can swap it out. Secondly, obviously the actual the bridging, right, itself is a trust assumption. So we kind of lucked out with this, but we identified that so Exocore has to communicate to these other blockchains in order to effectively lock, unlock, and slash the assets, and then kind of read the state to update the state on Exocore. So Exocore kind of is like a coordination layer across these different blockchains. And what we identified was, obviously for using, you have to kind of cross communicate to these different blockchains. How do you do it? So we implemented a ZK bridge, light client bridge, through layer 0 and polyhedra. And this is a pretty secure design, and the way we use it is also secure. So it's effectively a one-way, what they call a one-way state peg. So what happens is we communicate, we write to the chains where smart contracts are deployed on Ethereum and these other chains that we support, and then we do that to lock, unlock, and slash the assets, and then we read from them through a ZK light client bridge. So it's effectively it's trust minimized of a bridge as you can get. There's no minting, burning, there's no token transfer. So this is like your well-engineered bridge that you don't necessarily have to worry about crossing. And we made sure that was really, really important. The third one was, and this is probably where most of the security exploits happen, is at the smart contract layer. One of the reasons why we didn't necessarily like the design that EigenLayer had proposed is that all the restaking operations are within the smart contract layer. And what that requires is a lot of complexity with the smart contracts. And when you introduce complexity at the smart contract level, it's hard to audit. And when it's hard to audit, mistakes are made. And when mistakes are made, that's when exploits can happen. So we proposed a different design entirely, where the smart contracts are insanely simple. And this probably comes back from my original days of building, these rudimentary smart contracts on Bitcoin, which are really, really, really simple. And because they're so simple, they're very secure. So what all the smart contracts do on these different blockchains that we support are lock, unlock, and slash. And that's it. So we can ring fence during the security audit, and we can ensure that audit is highly reliable, because there's not much to actually audit. And so in that simplicity, we think that there's security. So that's kind of the one of the design principles that we really care about.
I know you're doing it right, even though I don't know how to code. Is my dad was a civil engineer who built bridges, and he always talked about the security and the structure. So you talked about the security. I was like, yeah, they're doing it right. So, sounds good. That's the first part of attack vectors, right? The second part of attack vectors is something that everybody has to deal with, and that is people like Elizabeth Warren, people like the government saying Bitcoin is used by, drug traffickers or whatever, and that has been, and the SEC falls in that bucket, right? Of, how do we mitigate those attack vectors as an industry?
Yeah, this is a a topic that's near to my heart. I was obviously at Ripple for 5 years, and they were sued by the SEC and came out victorious at the expense, I think, of several $100 million in legal fees. But I've been generally well, I've been understanding, but also disappointed at how the U.S. government has approached policy in crypto. What I would like to see, and I'm a student of history. For instance, during the Clinton administration, the topic of the internet was huge, right? And what to do with this open internet. And there were a lot of scammers. There were a lot of pornography and illicit use cases of the internet. Sound familiar? Well, the Clinton administration took a very hands-off approach, which was based on two principles. It was wait and see and do no harm. And those two principles were basically the bedrock of how the internet emerged in the United States. I would argue, based on the list of Fortune 500 companies and how much of them are internet-based companies, how much value they've created, how much value they've turned into jobs, etc., that I would say that policy was successful. It wasn't perfect, but it was pretty good. It was like categorically correct. And I think what's happening now in the US is the crypto policy is categorically incorrect. It's going in opposite direction of what it should be, which is very disappointing. Obviously Biden was around during the 90s and the Clinton administration, so I would assume he had a front row seat of how this evolved. So I don't know why he's not employing that same policy. He literally has the playbook, and just very curious. And I think that there are, unfortunately, special interests that are involved here that are effectively trying to kill crypto. When I say special interests, I primarily mean the banking industry. So what you have now is this regulation or policy or regulation by enforcement, which is something that just is anti-American, I believe. But democracy is messy, and it bends, but it doesn't break. So I think we're at a bending point where it's bending a lot, but I think ultimately it won't break. And I do think that what we're seeing lately is the people kind of pushing back. And there's 52 million Americans that own crypto. That's a significant amount. And guess what? They're mobile, they're active, they're politically active. I call my congressman and senator all the time saying, "What's the stance on crypto? I see you're on this list, and there's a question mark." And these other crypto holders are doing the same. So it shouldn't be illegal. It shouldn't be wrong to own crypto. Should be able to do it and participate in a decentralized market. These are all things that empower innovation, open innovation, permissionless innovation. So it makes America great. So I think what's going to happen is you're going to see this November that people are going to vote with their wallets, their crypto wallets in some form.
I am. I definitely am. I love the 90s because I thought the Clinton administration had a booming economy.
That's good times.
The finance was fun. So I want to shift and get into AI, but I have one last question regarding your structure, and it's something that I've seen a lot of VCs talk about, repeatedly, and I really don't understand. Maybe you can help me here. Modular, what you said, your platform is modular versus monolithic.
Yeah.
What's the difference, and what's the benefit of the modular versus monolithic?
Yeah, so one of my favorite, I don't know if your audience would relate to this, but I'm kind of a car guy, right? And you buy a car, you can buy like the car complete with everything, right? And it's kind of the engine, the transmission, it's all baked in. Or you can go kind of the route of like what you call Mopar, right? And Mopar is like Mopar Auto Part. You can kind of build your own car, and you could plug in all these different things. You could buy a crate engine. You know, I dropped in a crate engine back when I was in high school in a 1971 El Camino, and you know, completely swapped out everything. It was just fun to what they call mod. And so that's actually no different with how blockchains are, or these modular blockchains. Is if you want, you know, a different execution layer, you can use that. If you want a different consensus layer, you can use that. And you can actually pick these and piece them together, stitch them together. And the nice thing about modular blockchains is they are actually inherently future-proof, because if another better execution layer comes out, then you can actually swap it. It's not trivial to do, but you can technically swap it out for a new one. Same goes for consensus. Same goes for, you know, the kind of virtual machines. So there's all these different kind of modular kind of components that you can use. And restaking helps because it can help kind of provide this initial cryptoeconomic security for these modular components. So the fact that this modular movement is happening and restaking is happening at the same time is kind of perfect, because you have not just the components, but also the method to secure these components.
I understand it now. Thank you.
You're welcome.
That's great. So now I want to shift into AI, right? Right now, blockchain and AI are converging. You know, this I think they're converging, but that convergence, you know, what do you see that empowering?
Yeah, so right now we've been working on quite a bit of AI use cases. Right now, what's happening is there's kind of a groundswell for decentralized AI. Now, this is going to become, you know, a hot topic, right? Because currently the AI industry is highly, highly centralized. And not just that, but it's basically controlled by the same 4 to 5 FANG companies that, you know, we've grown to love and hate. And so this calls into question, you know, do we want the future of AI to also be controlled by these same companies? And what happens if like one of those AI systems goes rogue and there's no alternative, there's no open alternative. And so there's a lot of smart people that are working on decentralized AI, which is kind of like a counterbalance to the highly centralized AI that's converging. Now the question is, how do you secure that decentralized AI? And that's where restaking comes in, is you can extend that cryptographic and cryptoeconomic security from these blockchains to secure these decentralized AI platforms. Because there's very few teams or projects out there that have experts in both, you know, AI and, you know, cryptographic or cryptoeconomic security. We happen to be one of those teams that have both, which is very rare. But being able to effectively outsource your security to like an Ethereum, to a Bitcoin, to a Solana is really attractive without having to build your own Ethereum, Bitcoin, or Solana. So that's what restaking there, in our view, how restaking can insert itself into the kind of cross section of blockchain and AI. And so restaking can actually help empower this decentralized AI movement to ensure that there is an alternative, an open alternative, you know, just in case, you know, any of these big company kind of AI agents go rogue, we at least have something to kind of counteract that.
You remember you talking about going rogue? It was like my friends and I went to see Total Recall when it came out, and we were like, "Whoa, that was wild." And then we went to see the class of 1999, and then we were terrified. You know, it was like, if you haven't had a chance to see that movie, check it out. You know, it was many years ago, but you know, yeah, we were more afraid than we were trusting, right? And I know one of the things you're doing is you're scaling privacy to better improve trust. You're working on improving trust, and if people are fearful, they're not going to be trusting, right?
Yeah.
So, how do you scale? And private people are wary of privacy to begin with, right? So, how do we scale privacy and make it, trustable and improve trust with three?
Yeah, this kind of goes back to, the last few years when I was working on, ZK privacy for Web3. And ZK, meaning zero knowledge or zero knowledge proofs, is a really amazing technology that has it's one of those technologies that was invented in the 80s by Shafi Goldwasser and another MIT professor. And it's really this simple concept where you can effectively verify the truth of something without knowing what the underlying details are. And a simple case of this is like, I can verify your age without actually knowing what your birth date is. And this is like obvious, like this would be great because you wouldn't have to disclose your birthday to anyone. I could just say, yep, he's over 21, or whatever the threshold is, without actually knowing the underlying details. And this concept is very powerful. The reason why it hasn't reached kind of mainstream or more wide distribution is that there's really it hasn't been scalable until recently. There's a lot of use cases that are currently being used that are using zero knowledge proofs, mainly for a different use case for scaling what they call the like succinctness of zero knowledge proofs, where you're effectively shrinking a set of data to like make it more scalable. But there's an expansive set of use cases around privacy that can effectively, you can run these computations on this private data and get these results that are proving that something's true, like is the birth date over some certain threshold. And so right now there's a lot of effort going into scaling this technology. There's two ways to do it. One is increasing or like improving the arithmetic that goes in and like the math, which takes a while. And like when we talk a while, like many years. So improving the math, making it more efficient. And then the other way is to actually what they call accelerate the hardware. So it's literally called hardware acceleration, where you just make the chips way better at being able to run these proofs. And so there's actually efforts going on both sides. And this is very exciting because I think if the future, and again, if like policy can allow this, if everyone can be running on these ZK or zero knowledge proofs, then you no longer have to worry about data privacy issues. Oh, my data was hacked because some database was leaked. These databases can be secured and encrypted, where even if the hacker gets involved, they can't see anything because it's encrypted. But the problem is, how do you run all these computation and to use that data? Well, you can do it using zero knowledge proofs. So this is like this is almost as big as blockchain. I'd say even potentially even bigger, but can be used by enterprises, and blockchain is actually enabling this technology and helping to scale it, using these kind of these mechanisms, and kind of bringing this back to restaking. You can use these mechanisms to incentivize the servers to actually run these really complicated proving kind of verification systems.
We need the Clinton methodology of wait and see and do no harm.
Absolutely. I think hopefully at some point in the future we get a political leader that really is they don't have to be technical, they just have to be curious and optimistic about the future, but also cautious, but not in a way that's like going to hurt innovation. America was built on, the innovation. I think that's the one thing that America gets better than most countries. And if we kill that, that's bad news.
Yeah. Well, hopefully we have some good news coming down the pipe. We'll see. I want to thank you very much for your time today. I enjoyed speaking with you. And I have one last question. It's really easy. It's how can people find out more information about you, about Exocore? How can they reach out, or how can they do that?
Absolutely. So you can go to the website exocore.network, or just follow Exocore Network on Twitter, or X, formerly known as Twitter. I'm also on X at Warpaul, WARPAUL.
Awesome. Thank you very much for your time today.
Absolutely. Thanks for having me.